Welcome to lecture 24. We are studying basic electrical engineering. We are studying AC circuit analysis, and today we will solve a problem using nodal analysis. We have already studied nodal analysis for DC circuits, but today we will solve a problem with AC supply, and we'll find the required voltage. The procedure is the same. That we'll first identify a ground node, and then one or more than one nodes, and then we'll write KCL equation for each node. Here we identify only one node in addition to the ground node. We call the voltage of this node as V, and we start writing KCL equation for this node. Right. We have this branch connected to this node, branch number 1, the second branch, third branch, and this fourth branch. So we have 4 branches connected to this node, and let's write down equation for each of these branch. Right, each of these branches, right, V is the voltage here. This means the same voltage V here. Right. The current in this direction, since we don't know the direction of the current, we'll assume it to be going away from the node, right? So we'll write V minus the voltage drop 12, the voltage of the source 12 at an angle of 30 divided by 2 ohms. This is the current flowing outwards in this branch. Since we don't know the current in this branch, we'll assume it to be going away and write positive V divided by a 1 plus the current in this branch is V divided by J1 plus the current in the last branch. The total impedance of this path is 1 minus J1. So we'll write V over 1 minus J1 is equal to 0. So we have written KCL, Kirchhoff's current law equation, for this node. Since it involves many complex numbers, this is a complex number, this is a complex number having only imaginary part, and this is a complex number having this real part and this imaginary part. So interestingly, in this equation we have only one unknown, and which we can compute straight away. So this can be written as V by 2 minus 12 at an angle of 30 divided by 2 becomes 6 at an angle of 30, because this can also be thought of as a complex number with an angle 0. So 12 by 2 becomes 6, 30 minus 0 is 30, plus V over J1. J1 is a complex number having 0 real part, and imaginary part is J1. So it can be written as V over 1 at an angle of 90 over J2. Sorry, this is J2. So this is 2 at an angle of 90 plus V over 1 minus J1. 1 minus J1 when converted into polar form, R is 1 squared plus minus 1 squared becomes square root of 2, and theta becomes tan inverse minus 1 over 1 is minus 45 degrees. So the square root of 2 at an angle of minus 45 degrees is equal to 0. Right. So this whole equation, in order to get rid of this 2 in denominator, we'll have to multiply the whole equation by 2. So let's multiply this whole equation by 2. This is 6, this becomes 12, this becomes 2V, this becomes 2V, this becomes 2V. Right. So 2 over 2 cancels. This is V over 90 degrees, or it can be written as 1 at an angle of minus 90 degrees times V. If we take this complex number, divide this complex number, and angle, when we take it to the numerator, it becomes negative. So this 2 can be written as square root of 2 times square root of 2. So 1 square root of 2 cancels with this square root of 2, And this minus 45 once taken to the numerator becomes plus 45. Sweet. So we can now we have these terms involving v, right? And this is four terms involving v. So taking collecting coefficients of v, this is 1 plus 2 plus 1 at an angle of minus 90 degrees plus square root of 2 at an angle of 45. This whole multiplied by v, and this minus 12 at an angle of 30 taken to the other side of the equation becomes 12 at an angle of 30 degrees. Right. Adding this whole stuff, 1 plus 2 is 3. 1 at an angle of minus 90 degrees can be written as minus j1 in rectangular form, and square root of 2 at an angle of 45 can be written as x is equal to r cos theta, where r is square root of 2 cos of 45. Cos of 45 is square root of 2, so this is 1. And similarly, y is r sine theta, which also comes out to be 1. So this can be written as plus 1 plus j1. And this 1, j1 minus j1 cancel, and 3 plus 1, 4. V is equal to 12 at an angle of 30 degrees, or V is 12 at an angle of 30 degrees divided by 4. This means V is 3 at an angle of 30 degrees volts. Now we are almost done, because we need to calculate the output voltage V out, which is the voltage drop across 1 ohm resistor. Whereas we have this voltage drop V, which is across this minus j1 ohm capacitor and this 1 ohm resistor. So we can apply voltage divider rule. To find out the voltage drop across resistor. Right now we have the voltage drop across resistor and this capacitor. So V out is the voltage drop across resistor, taking 1 ohm in the numerator, writing this 1 ohm in the numerator, the sum of the two in denominator, multiplied by this V. V is 3 at an angle of 30 degrees. This 1 minus j1 converted into polar form is square root of 2 at an angle of 1 minus 45 degrees times 3 at an angle of 30 degrees. 3 over square root of 2 comes out to 2.12. And this 30 degrees minus 45 taken to the numerator becomes plus 45 degrees and adds into this 30 degrees. So V out, our required voltage is 2.12 at an angle of 75 degrees. This is how we can solve this AC circuit using nodal analysis. In upcoming lectures, we will solve more AC circuits using loop analysis, Thevenin and Norton's theorem. Thank you.